Hey guys, today we have a topic which will not only excite gamers but also people who are trying to get into machine learning or AI. So let's get started. So today we are going to discuss tensor cores. For a lot of people, tensor cores are not news, and yes, since 2017 NVIDIA has been providing tensor cores in their GPUs. But the reason that people are excited right now is because the accessibility has been increased. Now by accessibility I mean, in 2017 if you wanted a GPU with tensor cores, you had to buy the Titan V, which at the time costed $3,000, which is way more than an average gaming PC build, let alone a graphics card. And thanks to NVIDIA's new RTX series, these tensor cores are available at a fraction of the price. So first we learn the basics how these tensor cores work to see how it will translate into performance boost for machine learning algorithms, in turn providing better FPS in gaming as well. So let's clear out a major misconception that people have. A lot of people read articles like RTX 1660 Ti has 192 tensor cores and come to the conclusion that tensor cores are specialized cores different from CUDA cores. But this can't be any farther from the truth. If you actually analyze how tensor cores work, you will find that tensor cores actually are a functionality of a CUDA core rather than a specialized core created for ML or AI enhancements. So in short, unless and until you run a task that specifically requires tensor core to work, like a mathematical operation on matrices, your core would react as a regular CUDA core. So if it says a graphics card, let's say, have 200 tensor cores, it doesn't mean those are specialized cores. It just means that 200 CUDA cores are enabled to perform the tensor core functionality. Well, if it's just a functionality, why don't add it to all the cores and get that much amount of performance? Although the functionality doesn't affect how the core works in its default mode, however, it does affect the efficiency. So extending this functionality to all the cores is not that feasible. So let's see how these Turing Tensor cores perform when doing mathematical operations on matrices compared to the older Pascal architecture. As you can see, tensor cores are on a whole another level when compared to the older architecture. But remember, this is the case only when the workload is multiplication and addition of matrices. For a lot of people, this would be quite insignificant as we are just improving the performance to do some basic mathematical operations. But when you understand the actual scale of it, where terabytes of data has to be processed to run one iteration of that algorithm, and to increase the accuracy of that algorithm, you have to run thousands upon thousands of iterations, it does add up. So where it took days to train a model, now it would take a day or maybe less, increasing the productivity. So how will it increase the gaming capability of our system? Now this has not been implied as of now, but there are concepts where tensor cores could use neural networks to predict the next frame that your GPU is supposed to generate. So basically how it would work is, the metadata of the region that you're present in the game would be provided to the tensor cores, so that the cores would have an idea what kind of structures and objects are around you. Then by using the prior information about the scene, GPU will then predict how the shadows and the reflections would turn up when presented. So your GPU doesn't have to generate a new frame from scratch, but it would predict it. So this will decrease the amount of load on your GPU and boost its throughput. So if you like this video, please do like, share and subscribe. This is TechNoggin.